Welcome back to our second lesson. Last time I was explaining about whisking tubing being a semi-permeable membrane. The other one which we can use in this case is cellophane and dialysis tubing. So these are other whisking tubing semi-permeable membrane you can use in this case. Now, so how do you explain osmosis? Osmosis, when you separate solutions are separated by a semi-permeable membrane, there will be movement of water molecule from the region of their high concentration, which is the loose solution, to a region of their low concentration, which is the highly concentrated solution, across a semi-permeable membrane. So the semi-permeable membrane does not allow movement of solid particles across it. It only allows the movement of solvent particles. But solid particles, as I've already explained, are not allowed. The movement of the water molecules continue until the separate solution have the same concentration. Now you find that, let me show you something here. The idea is whisking tubing context. At the beginning, like this. Then, at the end of the experiment, we're going to have something like this. It's going to be swollen, but the contents are going to be now. At first, you see, we have a space here. So, at the end of the experiment, after 30 minutes, we are going to have this one filled, swollen. What is this supposed to tell us? It's telling us that the contents of the whisking tubing have decreased. And now, water molecules will continue moving in until a concentration is achieved that is the same inside and out. And when that point is reached, it's called isotonic. When that point in which concentration inside and outside is the same, solution with the same concentration are referred to as isotonic solution. So one thing I want you to, let me go explain this, then I'm going to do. Now we are going to use scientific term to explain this one. Now, a highly concentrated solution is called hypertonic. Highly concentrated solution is called hypertonic. Hypertonic, that means we can be having 80% solute and of course 20% water. When we talk about hypertonic solution, we are talking about a solution that has got 80% solute and 20% water. Then we can have another one called hypotonic. Hypotonic solution will be having 80% water and 20% solute. Now, coming back here, we have three types of solution. We have hypotonic, isotonic, so 50% water, 50% solid. Then hypertonic, 80% solute, 20%. Then hypotonic, we have 80% solvent. So this is solvent. Then we call it solvent. And we call this one solvent. Water is one of the solvent. 20% solvent. And these two form solution. Now, when we are in a situation whereby we have like this, and I don't mean that it can be 60, 40, it can be 55, 45. So long as the percentage of one, you are going to consider the percentage of one superseding the other. So, same concentration, isotonic. More solute, highly concentrated. This is highly concentrated. Highly. When we talk about highly concentrated, we are talking about solute molecules. Highly concentrated. But this one is dilute. Dilute is having more solvent than solute. Concentrated is having more solute than solvent, while isotonic has got the same percentage. Now, alone concentrated solution, dilute solution is referred to as hypotonic solution, which is this one here. A hypotonic solution has less of the solute molecules. Hypotonic solution has got less of solute molecules. Yes, molecules, but more of solvent. Less of solute, but more of solvent. Even if it's having solute 49, solvent 51, this is still hypotonic because it has got more solute molecules compared to what? It has got more solvent molecules compared to solute. Now, that being said, but more solvent molecule. Now, highly concentrated solution with more of the solute particles but less of the solvent particles is referred to as hypertonic. It's referred to as hypertonic. When isotonic solution are separated with a semi-permeable membrane, there will be no net flow because where will they be flowing to? You see, for osmosis to take place, one solution has to be concentrated while the other one has to be dilute, such that molecules can move from dilute to concentrated. But you find that when both of them, the solutions, have the same concentration, one, two, three. 1, 2, 3, 4. Now we have a scenario whereby we are having 4 water molecules this side, 4 water molecules this side, 3 solvent molecules, 3 solute molecules, 3 solute molecules. So you find that this kind of solution is the same. It is isotonic. Now, where will water molecule move from to where? So we find that in this kind of setup, there will be no movement of molecules in water because the solution is isotonic. There will be no net movement of solvent molecules to any of the solutions since they have the same concentration of solvent. Since they have the same concentration. Now, we want to talk about osmotic pressure. Osmotic pressure. Now we find that when you separate a concentrated solution from a dilute solution, the concentrated solution will develop a certain kind of pressure. And this pressure is meant to draw water molecules from the side with more water molecules to the side with less water molecules. And this solution, or rather this force, that is developed by a concentrated solution is called osmotic pressure. The concentrated solution will develop a force, and this is the force that is going to be used to draw water molecules from a distilled water, from a dilute solution to a concentrated solution. So that force that is developed by concentrated solution to draw water molecule from a dilute solution to a concentrated solution is what we call osmotic pressure. Now, osmotic pressure refers to the force with which one solution draws water to the side. Now, we are using osmometer as the instrument to measure what we call osmotic pressure. Now, we are having the measure of the pressure a solution, that concentrated solution will develop, withdraw water molecule from distilled, or rather from a pure water when separated by semiconductor membrane. The measure now of that pressure that solution is going to develop to withdraw water molecules from distilled water when separated by semiconductor membrane is now what we call osmotic pressure. Now, let me discuss about how does now this affect the organisms. Now, I don't know, how does osmotic pressure, rather osmosis now affect? We have less time, I don't know that we can continue. Now let's see. Because I think we are going to stop there because I need time to discuss about urination and hemolysis. If I begin now, I might leave it hanging so that we might not have, I might not, when I come back with the explanation will be hanging. So let us just leave it from this now. Next time we're going to discuss about relations in animals, how osmosis is affecting this process, or rather the cell. Now next time we're going to discuss how the behavior of cells, like red blood cell, when put in hypertonic, now I can use this one. When put in hypertonic, and when put in isotonic, and when put in hypotonic. So that's what we're going to discuss next time, such that you see how what is a relation. Thank you so much.